A pan of boiling water with a temperature of 100 degrees Celsius is set in a room with a temperature of 20 degrees Celsius. The water cools to 50 degrees Celsius in 40 minutes. We're asked to find values for T naught, D, and A so that the formula T of T equals T naught plus D times A to the T models the data where T is the time in hours. Alright, so dA to the T. Alright, so this is referring to Newton's law of cooling. And so we can immediately determine some information. For example, I know immediately that the T naught is 20. The T naught refers to the surrounding temperature. So we're told that the room has a temperature of 20 degrees Celsius, so T naught is 20. I also know that D is equal to the temperature of the object minus the surrounding temperature. And so D equals 80. So I can use that information to begin to revise the model. So I now have that T of T is 20 plus 80 A to the T. And now I just need to figure out the value of A. So now we use the remaining information. We're told the water cools to 50 degrees Celsius in 40 minutes. But wait a second, we need the time in hours. So 40 minutes is 40 out of 60 hours. That's 2/3 of an hour. So when the time is 2/3, the temperature is 50. So we have 50 equals 20 plus 80 times A to the 2/3 power. Solving for A, we would have, subtracting 20, we would have 30 equals 80 A to the 2/3. Dividing by 80, we would have 3/8 equals A to the 2/3. Now to solve for A, I would raise both sides of this equation to the 3/2 power, because that would give me A to the first on the right-hand side. 2/3 to the 3/2 power, you multiply those exponents, I'd have A to the first power. Now on the right-hand side, I would have quantity 3/8 raised to the quantity 3/2. And so let's approximate that. That would be, let's say it's about 0.230. So then my model is T of T is 20 plus 80 times 0.230 to the T. Part B asks us how long does it take the water to reach 30 degrees Celsius. So that's an output for this model. So I would need to solve the equation. 30 is 20 plus 80 by 0.230 to the T. Subtracting the 20 gives me 10 is 80 by 0.230 to the T. Dividing by 80, 1/8 is equal to 0.230 to the T. Now to solve for T, since it's in the exponent, we will apply the logarithm. I'll apply the common logarithm to both sides of this equation. So the log of 1/8 is equal to the log of 0.230 to the T. Using our property of logarithms, we have log of 1/8 is equal to T log 0.230. And dividing by 0.230, we have T equals log of 1/8 over log of 0.230. And we can use our calculator for that. See, log of 1/8 divided by log of 0.230. So T is approximately 1.4 hours.